Abby the Maths Tutor, and today I'm going to show you how you can find a missing side on the triangle, and hopefully by showing you how that relates to the area of some squares, it will be something that you will remember and be able to apply effectively. So first of all, I'm just going to draw squares on each side of this triangle at the top left. So those two squares are straightforward to do. The wonky square is a bit more awkward. I'll go up and across. I'll just need to do this one line at a time and then come back down. Now, when I'm finding the areas of these squares, the first two I drew is very straightforward. You could just count the squares, or you could do, well, you know it's 3 squared, it's 9. And we know that this one here is 2 squared, it's 4. When it comes to counting the third area, that's a little bit more awkward. What I'm going to do is come down from the top until I'm level with a corner, then go across until I'm level with that bottom corner, then up and then across. And the reason I've done this is just to make it easier to count. So if I imagine this triangle put together with this triangle, I'd have a 2 by 3 rectangle. That would give me an area of 6. Then if I go to the other two, I could put this one together with this triangle at the bottom. That would give me another rectangle of 6, and then I've got a 1 in the middle. So altogether I've got a 6, a 1. So that top square is 13. I can apply the same technique to each of my other diagrams if I want, going through and checking them off carefully. So here this needs a 4 by 4 square on the bottom. I'll just tidy that one up a bit. And then I'll draw the lines in for the one on the side here. So that's going to be 4 and 1. So now I've got my square. I'll do the same thing again where I'm splitting it up into different triangles. So I'll come down from this corner till I'm almost at the bottom and then go across, up and across. So this time you can see I've got 9 clear squares in the centre of it. If I piece together the part squares, I've got a triangle at the bottom, can go together with the triangle at the top. That would produce 4 squares in total. And then if I just do the same at the sides, the triangle on the left, if you put that together with the triangle on the right, it would make another 4 by 1 rectangle. So 4 there, add them up, 9, add 4 is going to be an area of 17. Now if I count what I've already got, the square on the left was a 1, the square underneath, there's 4 rows of 4, so I've got 16. Now hopefully you can see quite clearly with both of these diagrams that the area of the square on the bigger side is exactly the same as the area of the 2 smaller squares added up. And if I were to do it to that third triangle, we would find the same again. So this is the principle of Pythagoras Theorem, that the area of the square on the hypotenuse of a triangle is equal to the area of the sum of the squares of the 2 shorter sides. Now realistically, when we're calculating this, we want to be looking at the lengths of the sides. Well, if that 17 is the 1 and the 16 added up, then actually the length of that side will be the square root of 17. So I need to think about squaring the sides to get the area of the square and then square rooting the answer. So let's see what that would look like when we're actually wanting to do some calculations. So This diagonal side here is called the hypotenuse. We don't always see it as a diagonal because the triangle could be in any position at all. The triangle isn't necessarily going to be drawn that way round. Sometimes people can get caught out with this simply because the triangle is being turned. So if I get this and turn it, hypotenuse is down at the bottom. So the hypotenuse is the name of the side that is the longest side in a right angle triangle. In fact, it's the only side that does not touch that 90-degree angle. So there's a good way of remembering which one it is. So here's a triangle I'm actually going to do some calculations with. I am going to have that this is 5 centimetres. This can be 15 centimetres. My diagram is not to scale at all. And I would like to know this. The very first question I ask myself is, do I want to find the hypotenuse? In this instance, I do. So if I want to find the hypotenuse, I know that 5 squared add 15 squared will give me x squared, because that's what we found out from looking at the areas. So rather than writing all that out, I'm just going to go, oh, so I need to square it, add them up, and that will give me the area of the square on the side. I don't actually want the area of the square on the side, I just want the length. So x will equal the square root of 5 squared add 15 squared. And when you put that in a calculator, you will get a decimal answer. There's only a handful of calculations you'll do with Pythagoras that will give you a whole number answer, and those are Pythagorean triples. And if you spot them and learn to recognise them, it just means it's quite nice, because you'll go, oh, don't need my calculator for this because I can see what the answer is. This, however, is one that you would be wanting a calculator for. One comes out as 15.811. It continues a bit further than that, but that is more than enough decimal places that I've gone to. So that's finding a hypotenuse. Very often we might need to find one that is not a hypotenuse. So I'll just move the page up a little. So again, your first question is always going to be, do you want to find the hypotenuse? So on this one, I'll give you 7 centimetres and 20 centimetres, and we'll find y. So do we want to find the hypotenuse? No, we don't. We know the hypotenuse is 20. So if we were going to add up the two squares on the shorter side to get the square on the big side, then it makes sense that we're obviously going to subtract if we're going to find one of the smaller ones. So I know that 20 squared, take away 7 squared, will give me the area of the square on the side where y is. I don't want the area of the square, I just want the length. So I will put y equals square root 20 squared, take away 7 squared. And I can pop that into my calculator and do it all in one go. It comes out as 18.734. So sometimes when people do Pythagoras, in fact very often, they end up doing several lines of working out. It's not necessary to show all the separate stages to it. If you've got a firm understanding that what you're actually doing with Pythagoras is you're figuring out the areas of the squares on the sides added up will give you the area of the square on the hypotenuse, then you know what the steps are. You know that if you're just going to be getting a side, you'll be square rooting. So you're either squaring and adding to find a hypotenuse, or squaring and subtracting if you want one of the other sides. I hope that was helpful, and I'll see you next time.